If you want to find the worksheet I made, just go to ucfstudyunion.wordpress.com and then scroll till you see Alexis under Chem 2, and then you'll find this. And then later tonight, I'll post the other one with the answers. Yeah, we're going to start with Kahoot. So just log on, go to kahoot.it. Never? 1, 2, 3, 4. I did it so they made the names for you guys. Are you here for Chem 2? Yeah. I think it's in another room. All right, is everyone logged in? Yeah? Okay. Yeah or no? All right, we're going to start in like 20 seconds. Are you in? All right, we can start now. Yeah. Okay, what is the strongest covalent intermolecular force? Okay, so the key word here was covalent. Yeah, ion dipole is the strongest intermolecular force, but it's not the strongest covalent intermolecular force. Does everyone see that? Ion dipole has to do with ionic bonds, not covalent bonds. So you guys need to be very careful on the ACS. They will put a question like this and try to trick you. All right, we can go to the next question. If you're just walking in, it's kahoot.it and the game pin is on the bottom. All right, so which of the following substances has the lowest melting point? All right, it's kahoot.it, 2637239. The game pin's on the bottom. Okay, you guys chose the one that has the highest melting point, not the lowest melting point. So the lowest melting point would be the one with the least, or the weakest intermolecular forces, right? So it should be CH4, not KCl. KCl would be the highest melting point. All right, next. Okay, what kind of solid is a diamond? You can log on, it's at the very bottom. A diamond is network covalent. You guys need to read your textbook before your exam and make sure you go and outline all the chapters. All right, next. Okay, which one would be most soluble in SO3? So this is chapter 12 or chapter 13 in a new book. All right, so SO3 is trigonoplanar. If you were to draw it out, you would have saw it trigonoplanar, and then they will all cancel out, making it nonpolar, right? If you're nonpolar, you only have LDF. So you should be looking for the one that would be nonpolar and only have LDF. All right, we're good. Okay, which substance would have the lowest vapor pressure? I actually want to skip this question. Can we skip this? Yeah. I have a question like this in the review. I'm just going to do it on the review. Yeah, the next. Okay, via activation energies, which happens to create the slowest reaction? So think about that activation energy graph. Hi, we're just playing Kahoot right now. All right, so the one with the highest activation energy would be the one that's the slowest reaction. So if you think back to the activation energy graph, you have to think about going over this hill, right? So the one with the highest activation energy would be the slowest reaction. All right, we're good. What is the rate law of the following reaction? You guys. Okay, so you cannot determine the rate law without doing an experiment or without the reaction mechanisms. So you cannot look at this problem and just give me the rate law. You can find me the K, the equilibrium expression from this, but you cannot find the rate law. The rate law has got to be determined experimentally. All right, next. What is a catalyst? So all of these are what a catalyst does and what a catalyst is. Next, yeah. All right, if K is very small in comparison to 1, then what? All right, so if K is very small in comparison to 1, then the reverse reaction will be favored. Next. All right, so you have calcium carbonate at equilibrium with CaO and CO2. What would happen if you increase the concentration of calcium carbonate? I'm tricking you guys. All of these questions are to trick you and what the ACS will be. I want to make sure that you guys are prepared for the exam. So, Le Chatelier's principle, right? Going back to equilibrium, what two phases can be in your equilibrium? Yes, aqueous solutions and gases. Solids and liquids are not included in your equilibrium. So if they're asking a question about a solid in the Le Chatelier's principle, it's not going to have an effect on it because it's a solid. All right, next. All right, which pair is a Bronsted-Lowry acid base pair? All right, yeah, so H2SO4 and HSO4 minus would be the acid base pair. I'm good. All right, which ion will form a basic solution when dissolved in water? Okay, so you have Br minus, NO3 minus, SO3 2 minus, and HSO4 minus, right? If you were to add a hydrogen to each of these ions, that's what we're doing. So if you were to add a hydrogen to Br minus, you'll get HBr, which is an acid. If you add an H to HSO4 minus, like if you have HSO4 minus in water, what would that yield? That would yield H2SO4 minus or SO4 2 minus. I think this is the one I had wrong. SO4 2 minus versus the other one, if you were to add water, it would be HSO3 minus. I think either way, it would be either answer, the diamond or the triangle or the square. Let me just make sure. If you had HSO4, say you had HSO4 minus in water, it can either do this, so it can either do that or that. So here it would be acting as a base, right? HSO4 minus plus water, it's accepting, so this is the base. So it can be a base or acid. So either, actually, I put two correct answers. So it could be the triangle or the square, and this is how. And if you had SO3 2 minus, all right, we're good. All right, so after adding a certain amount of base to a flask of acid alone, the flask turns a dark pink. What will happen? Or what does this mean? So I know a lot of you guys haven't taken the chem lab. I'm not quite sure if the ACS does include lab questions, but if it does, you should still look over what they could ask you. And this would be one of the questions that could pop up on the ACS. Hmm? Yeah, no, they won't ask anything that's not in the book. And if they do, your professor may curve the grade versus that question because you guys never went over it. All right, so if you see a dark pink, it's past the equivalence point. If it's like a very pale pink, that's at the equivalence point. And if it's still clear, it's before. All right, next. In which conditions is the reaction spontaneous at all temperatures? All right, so when it's exothermic and positive entropy, that's when it will be spontaneous at all temperatures. All right, next. Okay, so which of the following is spontaneous? All right, so a bike going up a hill, a bike won't just go up a hill by itself. So that's what you have to think about. Will any of these processes react by themselves or happen on their own? All right, next. Okay, so write the following reaction that's been written in electrochemical cell notation. Okay, great job. So the electrochemical cell notation, it always goes anode and then the ion, and then the two lines are always the salt bridge, and then another ion, and then the cathode. Only ions flow through the salt bridge, so that's why the ions go right next to the two lines. And then the anode, oxidation occurs at the anode, so we're looking for which one will show that zinc is losing the electrons and not gaining the electrons. So if I'm going to zinc solid to zinc 2+, it's losing 2 electrons. So the triangle answer would be the one that's written correctly. All right. So great job, Wise Dolphin. You only missed 6 questions. All right, so we're going to do the UCF Study Union review that I made. It's on ucfstudyunion.wordpress.com. Just click on chemistry, then scroll to Chem 2 with Alexis, and then you'll find that there. All right, so the first question, which of these molecules have the highest boiling point? Does anyone know? So what are we looking for when we're looking at boiling point? Yes, we're going to look at the strongest intermolecular force. So let's look for strongest IMF. So we have CO2. What does CO2 look like? What does it look like? On both sides? I don't have my periodic table with me, but 4 plus 6 times 2, so 4 plus 12 would be 16. So 2, 4, 6, 8, 10, 12, 14, 16. So this would cancel out, making CO2 what? Nonpolar, and have LDF. CH4 we know is nonpolar and only has LDF. We see that question a lot, so we should know what it looks like. CH3, OCH3. This kind of looks like water, doesn't it? So we know it would be bent. And then you have CH2Cl2. So you have CH's and then chloride. So since these are both dipole-dipole, it's very zoomed in. It's not even moving. Okay, so if these are both dipole-dipole, what do we look at? The mass, right. So which one would be heavier? D? How much is the mass of chlorine? It's 36, right? So you have two 36s and oxygen's only 16. So the answer should be B. All right, number 2. What happens to the vapor pressure of a substance when its surface area is increased at constant temperature? All right, so they're asking about vapor pressure, but you guys learned in the book the relationship between the rate of vaporization and surface area, not just vapor pressure. So for this question, it's going to remain the same. So the rate of vaporization increases with increasing surface area. So rate of vaporization increases with increasing surface area. The vapor pressure of a liquid is independent of the surface area, and an increase in surface area increases both the rate of vaporization and the rate of condensation. So these effects will exactly cancel and the vapor pressure would not change. So the answer would be B. All right, so which property of a liquid increases with increasing temperature? What is viscosity? The what? The ability to flow. So if you're more viscous, what does that mean? Yeah, it's harder to flow. You're going to flow much slower than if you were less viscous. So if you increase the temperature, viscosity would decrease. So it won't be B. But we know with vapor pressure, when you increase the temperature, the vapor pressure will increase. All right, number 4. Which process releases the greatest amount of heat? So they gave us condensation, freezing, boiling, and melting point, right? Do you guys remember the heating cooling curve? So I'm going to draw that on my paper. Okay, so all of these are at where on the heating cooling curve? At the plateaus, you can find these. And what is the equation for the plateau? I know it's been a while. Q equals N delta H. All right, so at the plateaus, we're going through a phase change, and so we're going to use Q equals N delta H, correct? All right, so there's 2 parts to this question. One, which process releases, so that's one key word, and the other one is the greatest amount of heat, right? So let's start off with figuring out which one is releasing. So what are we looking at? Yeah, but more specifically? Exo and endothermic processes, right? So which processes are exothermic? Because that's what we're looking for. Condensation and what else? And freezing. And then these would be endothermic. All right, so we can go ahead and cross out C and cross out D. Now we want to figure out which one has the greatest amount of heat. Well, remember those delta H's? You had to remember those. So what was the delta H for this first plateau? For delta H fusion? Yeah, it's around 6. And then what about this delta H? It's around 40.7. So this one would have the greater delta H, so the answer should be A. Does everyone see that? All right, so which part? The whole thing or the second half? The second half? All right, so we're trying to figure out which one would have the greatest amount of heat. So if it's Q equals N delta H, N is going to be the same for all of them because we're all talking about water. So then if we're looking at the delta H's, the delta H of the phase change for melting and freezing is around 6, and the delta H for the phase change for condensation and boiling is around 40.7. So the greatest amount of heat released would be with condensation versus freezing. Mm-hmm. All right, number 5. Consider a substance having a triple point at 885 millimeters mercury and 145 degrees Celsius. If the sample is initially at 175 degrees Celsius and 925 millimeters mercury, what phase transition occurs when the pressure is decreased to 760 millimeters mercury at constant temperature? So normally on the ACS, they'll probably give you the diagram. But if they don't, you should also be able to answer the question. All right, so it's a triple point at 885 millimeters mercury. So 885. And then here, the temperature is 145 degrees Celsius. So now they're saying if the sample is initially at 175 degrees Celsius and 925 millimeters mercury, what phase transition occurs when the pressure is decreased to 760? So what phase transition is that? So we have solids over here, a liquid, and a gas. So if we're going to a liquid to a gas, what is that? Evaporation. So liquid to gas, which would be B. Melting would be what? Solid to liquid. Sublimation? Solid to gas, and then freezing. Liquid to solid. So I don't know if it would help to do all of this first and then go look for the transition so you can do it quicker, but either way. All right, are there any questions regarding this one? Okay, number 6. Rhodium crystallizes in a face-centered cubic unit cell. The radius of a rhodium atom is 135 picometers. Determine the density in grams per centimeters cubed. Okay, so face-centered cubic is how many atoms? 4 atoms. And what is the length equation for it? 2r square root of 2. And then we know that density has to be in grams per centimeters cubed. So let's change our picometers to, what did I do? All right, let's just do the length first. So length equals 2 times 135 picometers, square root of 2. You're going to get 381.83 times 10 to negative 12 meters. We have to change that into centimeters. And you'll get 3.81 times 10 to the negative 8 centimeters. To get centimeters cubed, that is volume. So we're just going to cube that value. and you'll get 5.567 times 10 to negative 23. If you see any value that is around 22 through 24 over here, then you have done this correctly. For any part, if you're trying to figure out the density and you have found the volume, you want it around this, and that's how you know you're on the right track. If you don't get a value close to this, like if you got negative 10 to negative 10 or 10 to negative 12, you've done something wrong and need to go back and start over. And then you'll see why at the end. All right, so now after we found the volume, let's find the amount of grams. So we're starting off with 4 atoms. And we know that there is 6.022 times 10 to the 23rd, Avogadro's number. This is that amount of atoms per 1 mole. And then after looking up on your periodic table, you saw that rhodium was 102.91 grams per 1 mole. And then you should get 6.86 times 10 to negative 22 grams. So in order to find density, you would do, this is centimeters cubed. You would do, yeah, that's 102.91. So density would be 6.86 times 10 to negative 22, all over 5.567 times 10 to negative 23. You see how negative 22 and negative 23 is really close to each other, so it's showing you that you are on the right track. And your density would be 12.4 grams per centimeters cubed. Does anyone have any questions? All right, does everyone have it written down? Yes? Okay, I'm just going to assume yes. All right, so the answer for number 6 is B. All right, number 7, which type of solid is dry ice? Does anyone know? What'd you say? Yes, that's correct. So number 7 is B, molecular. Which type of solid is dry ice? It's molecular. Diamond is what? Network covalent. All right, number 8. Which compound is soluble in hexane? Or which compound is the most soluble? I heard C. C is correct. So hexane, what kind of intermolecular forces is hexane? Or what kind of bonds does hexane have? Huh? Okay, that's intermolecular force. So it's covalent bonds. And it's nonpolar because it's a hydrocarbon. So if it's nonpolar, it will have LDF and LDF only. And so that's what we're looking for. So the answer would be C. These two will have hydrogen bonding. All right, number 9. Which aqueous solution has the highest freezing point? Before I ask that, do you guys know your 4 colligative properties? Can someone tell me? freezing point depression, vapor pressure lowering, boiling point elevation, and osmotic pressure. So normally in a solution, if you had pure water in one beaker, and then you had pure water and you add salt in it, will it have a higher or lower freezing point than the pure water? It will have a lower, because our colligative property is freezing point depression. So normally, the more that you put would be the lower the freezing point. This question, however, is asking for highest freezing point. So what are we looking for? The smallest value. So you guys need to pay attention to when you're reading the question, because you can go ahead and choose C, and C is incorrect. All right, so for the first one, we're looking at, for all of these, we're looking at the Van Hoff factor, because we're looking at delta TF equals I times molality times KF. If it's aqueous, it's all going to be dissolved in water, so all of their KFs will be the same, because the KF is always going off with the solvent. So we can ignore KF. So for this question, we're just looking at the I and the molality. So the first one is sugar, glucose, right? Or sucrose, one of them. And then your I would be what for an organic compound? 1. So you have 1.25 times 1, so this value would be 1.25. For the second one, you have K3PO4. What is that Van Hoff factor? How many? You can put your fingers up. It should be 4. So the Van Hoff factor for this is 4. So if you have K3PO4, you know PO4 is a polyatomic ion, right? And it's PO4 3 minus. So you have 3 Ks, and you know the K is -1 or +1. So that's 3 Ks and then 1 PO4. So it'll be 4 times 0.5, which is what? For C, what is the Van Hoff factor for NaCl? 2. So you have 2 times 2, and you'll have 4. And then what about for magnesium sulfate? 3. So the I will equal 3 times 1, and it'll be 3. So what would be the answer to this problem? A. Does everyone understand why A is the correct answer? Yeah? Okay, let's move on to the next one. All right, so it's asking, what is the vapor pressure of a solution with a benzene to octane ratio of 1 to 2? The vapor pressure at 50 degrees Celsius for benzene and octane will be respectively 280 millimeters mercury and 400 millimeters mercury. So this is also chapter 12, or 13 in your new book. So you have the pressure equations that you guys should remember. You know PA will be the mole fraction of A times the pure pressure of A. PB would be the same thing. And then P total would be PA plus PB. Or in this case, P octane and P hexane. So for this question, we have benzene and octane. Benzene had 280 millimeters mercury, and octane had 400. And they said it was a 1 to 2 mole ratio. So what would be our total moles? 3. So our total mole will equal 3. So for benzene, its mole fraction would be 1 over 3. And the mole fraction for octane, yeah, would be 2/3. So then for p-benzene, we would do 1/3 times 280. And p-octane would be 2/3, 280, or 400 millimeters mercury. And then you would add them together. So for this one, you should get 93. And then for this one, you should have around 267. So if you were to add the two, you would get the P total to be 360 millimeters mercury. So your answer should be C for question 10. Does everyone have this work on their paper? Yeah? All right, so number 10 would be C. Okay, number 11. The osmotic pressure of a solution containing 22.7 milligrams of an unknown protein and 50 milliliters of a solution is 2.88 millimeters mercury at room temperature. They want you to determine the molar mass of the protein. So the osmotic pressure equation is big pi equals molarity times R times T. So we know molarity is moles of solute over liters of solution. Our R would be 0.08206 liters per atmosphere mole Kelvin. And then our T has to be in Kelvin, so it will be 25 degrees Celsius because that's room temperature, plus 273. You'll have 298 Kelvin. So our pressure needs to be in millimeters mercury, or it needs to be in atmospheres. So we have 2.88 millimeters mercury, and the conversion would be 760 to 1 atmosphere. So our pressure should be this in atmospheres, 0.0037894. And then we're just going to plug all of this into our equation. So you'll have 0.0037894 atmospheres. And we're going to solve for molarity. So then you'll get 1.5 times 10 to negative 4 for molarity. And this is equal to moles over liters of solution. In the question, they said we had 50 milliliters. And then how many milliliters are in a liter? So it should be 0.05 liters. And then you'll solve for moles. And you'll get 7.697 times 10 to negative 6 for moles. And then they gave it to you in milligrams, so you need to make sure you convert milligrams to grams. And that was 22.7 milligrams, or 22.7 times 10 to negative 3 grams over our moles that we just solved for. And you'll get density, or not density, what are we looking for? You'll get the molar mass. So the molar mass of this unknown protein should be 2.93 times 10 to the third grams per mole. Are there any questions? Yeah. Okay. Is everyone good with this problem? Yes? Okay. So the answer for 11 should be C. All right, number 12. If each substance listed here costs the same amount per kilogram, which would be the most cost effective as a way to lower the freezing point of water? And we want to assume complete dissociation for all ionic compounds. Which one can we automatically cross out? Which one? A. Yes, we can automatically cross out answer choice A. It is not ionic, and it's going to have a Van Hoff factor of 1, and all the other ones will have a Van Hoff factor of 2. All right, so now we're just going to compare them. So all of these have the same Van Hoff factor. So what are we going to look for? Yeah? Yeah, we're going to look at the weight. So which one would be the smallest? So all of them have chloride ions, right? And we know chloride is 35.45 on your periodic table. So we can automatically, these two would be the heavier ones versus B and C. So we're trying to look at the cost-effective way to lower the freezing point of water. So we need to decide, are we looking for the heavier one or the smaller one, right? So distinction between B and C and D and E. So you guys won't be able to read that. I'm just going to have to rewrite it. All right, so I sat here this morning and I was trying to figure out how can I explain this, or how can you on a test figure out how do you do this problem if you've never seen it before, right? So let's just say they both were 5 kilograms. Because we're saying for the same amount of per kilogram, right? So I did NaCl versus MgCl2. So you have 5 kilograms. If you do times 10 to the third to get 5 times 10 to the third grams. All right, so they still have the same weight. So now you're going to multiply these weights by their molar mass. So you had 1 mole over the molar mass of NaCl, which is 58.44, and then 1 mole over 94.9. So for salt, you actually get 85.56. And then for MgCl2, you get 52.68. All right, and so the Kf we're ignoring because it's in water. They all have the same solvent. We're talking about water right here. So comparing these two, you get more out of salt versus you do with MgCl2. You get a bigger change in freezing point with NaCl than you do MgCl2. So they're looking for the one that's the smallest. So the answer would be B. Does everyone see that? How we talked ourselves through that problem? Yeah? Yes or no? You're looking at me confused, Edwin. Okay, so you guys need to be able to do the same thing by yourself on the ACS. Okay, number 13. I'm going to ask you this question again. What is the rate law of the following reaction? Cannot be determined. Yeah, if it's asked for the rate law, you have to be given the trials or the reaction mechanism. You cannot determine the rate law just off of this. If you're trying to find the rate constant, you'll have to have the trials. If they were asking for the equilibrium constant, then yeah, you can give them that. You need to distinguish equilibrium versus rate. They're two different things. Okay, number 14. Dinitrogen monoxide decomposes into nitrogen oxygen when heated. The initial rate of the reaction is 0.022 molar per second. What is the initial rate of change of the concentration of N2O? So if you guys remember from the book, you had rate equals -1/2 change in concentration of N2O over change in temperature, or change in time. And then it would be positive 1/2 for N2. And then positive 1/1 for oxygen. But this question's only asking about rate and N2O. So it's only asking about this. And they gave us the rate to be 0.022 molar per second. And we're trying to solve for the change, the initial rate of change. And this would be the initial rate of change. So then all we have to do is multiply 0.022 times -1/2, or divide it, 0.022 times -2. So you'll have, the answer would be C, -0.044 molar per second. Are there any questions? No? I can move on? Okay, I'll wait. You're good? Okay, number 15. For the reaction 2A plus B yields C, the initial rate was measured at several different reactant concentrations. From the tabulated data, we need to determine the rate law for the reaction. So I'm going to try and squeeze this all here. So let's solve for A first, the order in respect to A. So we would pick two trials. So I'm going to pick trials 2 and 1. So it will be 0.10 over 0.05 raised to the m equals 0.05 over 0.05 raised to the n, and then 0.070 over 0.035. This we can ignore because 1 to the whatever will always be 1. So 0.10 over 0.05 is 2. So 2 to the m equals 2. So 2 to the what equals 2? What would m be? 1. So now we can go to our answer choices and cross out everything that doesn't have a raised to the 1. So B would be incorrect and D would be incorrect. So now let's do B. Let's try and solve for B. In this case, for A, there is none that is the same. But it's okay, you can still solve for it. So let's just pick two values, or two trials that we want to use. So I use trials 3 and 2. So 0.2 over 0.1 raised to the 1, because that's what we just solved for. And then that's multiplied by 0.10 over 0.05, and then 0.56 over 0.070. So 0.2 divided by 0.1 would be 2. So that's 2 times 2 to the, to the n. 2 times 2 to the n equals 8. So now we're going to isolate this 2n, or 2 to the n. So 8 divided by 2 is 4. So the answer would be 2 to the n equals 4. Therefore, n would be what? 2. So the answer should be C. Question? Yeah, so you have 0.10 over 0.05, and that's 2, so 2 to the m. You have 0.05 over 0.05, that would equal 1. 1 to whatever will always be 1, so you can ignore it. And then you have 0.07 over 0.035, and that is 2. So 2 to the m equals 2, and so that's what we're solving for. And if it was 2 to the 1, you'll get 2, so m will equal 1. Is everyone good? Okay, number 16. A decomposition reaction has a half-life that is independent of its initial concentration of the reactant. What is the order of the reaction? How many people say 0 order? How many people say first order? How many people say second order? What's the last one? And how many say it cannot be determined? All right, so the answer is actually B, first order. If you remember, the half-life equation for first order was 0.693 over K. It's the only half-life that you don't need the concentration. This is a very popular question, by the way. And they can ask it in several different ways. Okay, number 17, we should know this question. Which statement is true regarding the function of a catalyst in a chemical reaction? Yeah, it should be all of the above. So 16 is B, 17 is D. All right, moving on to number 18. A plot shows the rate of the decomposition of SO2-Cl2 into SO2 and Cl2 as a function of 1 over concentration of SO2-Cl2. What is the order of this reaction? How many people say first order? How many people say second order? How many people, what did I say? Where did my paper go? Oh. It's C, second order. So 1 over concentration of SO2-Cl2 over, as a function of time. If it was just concentration, it would be what? Oh, I think I drew these wrong. Don't look at these. Okay. Yeah, if it was just concentration, it would be 0 order, and it would be a positive or negative slope. Negative slope. If it was ln of the concentration versus time, what would it be? First order, and that would be positive or negative slope? No, negative slope. That's why I drew this wrong. Second order is positive slope, 1 over. Okay, number 19. A reaction in which A, B, and C react to form products is first order in A, second order in B, and 0 order in C. By what factor does the reaction rate change if A is doubled, if the concentration of B remains the same, and the concentration of C is tripled? So it helps to draw out the rate law first. So rate equals K times the concentration of A, and they said it was first order. They said it was concentration of B was second order, and C was 0 order. So I'm just not even going to include it. So now we have to figure out what would happen. How many people say A? Too fast? Okay, so now how many people say A? How many people say B? How many people say C? And how many people say D? Okay, the answer is actually A. So I'm going to do it with you. So you have rate equals K. If A was doubled, it would just stay with 2. So doubled would be 2. And then it's raised to the 1. So 2 to the 1 will still be 2. And then you have B. B remained the same. So I'm going to say that's 1. Whatever to the 1, it was going to say that number. So 1 to the squared, and this would still be 1. So 2 times 1. And if C is tripled, you have 3 to the 0 order, and that would be 1. So the answer would therefore be 2. All right, is everyone good with this question? Question? What'd you say? Okay, so when they do this, I always draw out the rate law. And then if it said doubled, I would say that is a value of 2. If it's remained the same, I'll say that's a value of 1. And if it triples, I'll say that's a value of 3. Or quadruple will be 4. And then I go and I put that number as a placeholder for A, B, or C in my rate law. And then so per rate law, you'll be able to solve for it then. Okay, number 20. The half-life of a sample is 4.12 days. How long will it take for 75% of the sample to decay? Okay, how many people say A? How many people say B? C? D? Okay, so we want to know how long will it take for 75% of the sample to decay. So we're going to go, we always start off with 100%, right? So after 1 half-life, or 4.12 days, you now have 50% of the sample left. After another half-life, you're down to 25% of the sample there, right? But how much of the sample has decayed? 75. So a second half-life would be 8.24 days, so the answer should be B. Okay, number 21. We're going to consider this following rate mechanism, and I want to know what best describes AB2. So we're looking at what best describes this right here. What's the answer? Yes, it's an intermediate. What would be AB? Or one of the ABs? It'll be a catalyst. So one of the ABs are acting as a catalyst. All right, easy question. Number 22. Express the equilibrium constant for the following equation. Huh? A catalyst is something that's present in the beginning of the reaction and then present at the end of the reaction, as in it was something that was used but it wasn't taken up. Yeah, the answer for 22 is C. I'm sorry, like all of these answers are C. I'm very bad at making tests. I would have been freaking out on my test if I was bubbling C all this time. It was all C? Oh, that's crazy. Okay, number 23. Consider the following reaction at equilibrium. What is the effect of adding what's the effect of adding additional CaO to the reaction mixture? What's the answer? Is it A? Okay, let's go back to Kahoot. What was the answer when we did the Kahoot? No change. Because why? Yes, because it's a solid. You need to keep in consideration your phases. But if it wasn't, it would be to the left. So 23 is D. All right, 24. Considering the following reaction at equilibrium, what is the effect of decreasing the volume of the reaction mixture? What do we keep in mind when it comes to volume? Moles of what? Gas. So for volume, moles of gas. What also goes along with volume? Pressure. So if we are decreasing the volume, would you rather have more or less people with you on an elevator? Less. So where are you going to go? To the place where there's the least amount of moles of gas. So there's no moles of gas in the reactants, so we're just going to shift that direction. So the answer should be B. If we're increasing the volume and you're in this big room, would you rather have more or less people at your party? You'd rather have more. So this is how you can think about it on your test. And then pressure. Pressure, if you're increasing the pressure, that means you're decreasing the volume. And if you're decreasing the pressure, you're increasing the volume. Okay, number 25. Consider the reaction between NO and Cl2 to form NOCl. So it's saying a reaction mixture at certain temperature initially contains only NO and Cl2 at 0.5 molar. After the reaction comes to equilibrium, the concentration of NOCl is 0.3. We want to find the value of the equilibrium constant at this temperature. So what's the first thing that I always say that we should do? Write the K expression. So you have K equilibrium equals NOCl squared over NO squared over Cl2. What type of equilibrium problem is this? What do we have to do? I circled it as I was writing, or as I was reading. If you see initially and you see equilibrium, what do we have to do? An ice table. So we have 2NO plus Cl2 at equilibrium with 2NOCl. So we had 0.5 initially for these two, and then we had 0.3 at equilibrium for NOCl. So in this case, since we do have an equilibrium value for one of them, we are not going to use X. Oh, and there was 0 for initial for NOCl. So the change for NOCl is plus 0.3. The change of NO, however, would be minus 0.3 because they have the same mole-to-mole ratio. It will be 2 to 2 or 1 to 1. Looking at Cl2, however, it's a 2-to-1 ratio going from NaCl to Cl2. So what would be the change for there? Will it be half or double? Half. So it should be minus 0.15. Oh, I think I wrote this out wrong. 25. Oh, no, I didn't. Okay. So you should have 0.2 and then 0.35. 0.3? I know. I'm trying to explain. 0.3 is the change for NaCl, but that's a 2 for the moles, and it's 1 for Cl2. So if you're going from 2 to 1, you're going to half it. So that's where I got negative 0.15. Okay, so then this is your equilibrium value. So all you do is plug that into the K equilibrium expression that you did in the beginning. So the K would therefore be 0.3 squared over 0.2 squared times 0.35. So your answer should be C. Is everyone okay with this? Yes? All right. Number 26. Which of the following is a weak acid? How many people say A? How many people say B? Yes, okay. Everyone knows that HF is a weak acid. Okay. Which pair is a Bronsted-Lowry conjugate acid-base pair? A. Yep. Does everyone understand why? Huh? You don't? Okay. Oh. Okay, so let's move on to number 28. So you have an HNO3 aqueous solution with a pH of 1.75. What is the molar concentration of HNO3? What kind of acid is this? Strong. Huh? Oh, strong acid. All right, so we have pH equals 1.75, and we have HNO3. It's a strong acid, so what do strong acids do? Yes, they completely dissociate. So you have H plus and NO3 minus. All of these are 1-to-1-to-1 ratio, so whatever H plus is, NO3 minus is, and whatever NO3 minus is, HNO3 is, right? So all we have to do is just solve for H plus, because they gave us the pH. So 10 to the negative pH would give us the concentration of H plus. So 10 to the negative 1.75 would be 0.018 molar. So that would be the concentration for H plus. That would be the concentration for NO3 minus. And that'll also be the concentration for HNO3. So the answer should be D. All right, number 25. Find the pH of a 0.155 molar HClO2 aqueous solution. And they give you the Ka. What kind of acid is this? A weak acid. So what do we do for weak acids? An ice table. So we're going to have HClO2 in water, and that's going to create ClO2 minus and H3O plus. We have 0.155 molar for HClO2. Water is a liquid, so we ignore it. ClO2 minus, we have none, and H3O plus, we have none. So minus x, 0.155 minus x, and plus x. So your Ka would equal x squared over 0.155 minus x. So normally you would have to do a quadratic, but who likes doing those? I don't. So we're just going to solve for it. For acids and bases, you should be able to do it without a quadratic. And if they gave you a titration, or if they gave you any math problem or equilibrium, it won't be a quadratic on the ACS. There's barely any math, so they're not going to give you that anyway. So we're going to solve it without doing the quadratics. So for x, you'll get 0.04129. And so that is the value of both ClO2 minus and H3O plus. So then if you were to take the negative log of that, you'll be able to get the pH. So I crossed out my answer. If you put this in your calculator, what do you guys get? What did you say? C? I think the answer is really B, but that's if you did quadratic. We're not doing that. I just wanted to show you if you were to get a question. For this problem is 1.39. If you wanted to, I'm just saying, like, if you got a question like this on your exam, this is what you would do. You won't have to do a quadratic, so there is no point in me showing you a quadratic at this point. Okay, number 30. Which ion will form a basic solution when dissolved in water? The answer is D. Okay, so dissolved in water. So Br minus plus water would be HBr plus OH minus. And this would be HNO3 plus OH minus. And then this would be H2SO4. Wait, am I doing this wrong? Yeah, I am. Let me get a paper. Because they want to know which one will form basic, so all of them should be acidic, except for that one. So you have Br minus and water. But would it not be H3O? I mean, would it not be OH minus? Am I just confusing myself? I know the answer is D. I'm just trying to figure out how did I explain that. I don't remember. Huh? No, I didn't write all of them down. What'd you say? If anything, this question is from your book. Pretty much all these questions are from your book. I don't remember. Yeah, but I think that's for more so for number 31. There's a section in your book that talks about anions, and then there's a question that goes to it. And there's a good explanation for it, but I haven't read the book in like 2 years. So this is your class, not mine. But yeah, the answer's in there, or the explanation's in your book, but the answer is D. I know it's D. I know that much. Okay. Number 31. This one I can explain. Which compound will form an acidic solution when dissolved in water? So NH4 dissolved in water would become NH3. And then you have Cl minus will become HCl. NH3 is what type of base? What type of base is NH3? Weak. What type of acid is HCl? Strong acid. Which one's stronger? The acid, right? So what type of solution would that be? Acidic. So the answer is A. But let's keep going. You have NaOH and HCl. What kind of base is NaOH? So we have a strong base and a strong acid. So this would create a pH neutral solution. What about C? You have KOH, which is what type of base? And then you have HNO2, which is what kind of acid? Weak. So what type of solution would that be? Basic. Then you have CaOH2, which is what? Strong. And then you have HNO3, which is also strong. So this would also be pH neutral. So your answer would be A. All right, number 32. We want to find the pH of 0.175 molar NaCN solution and then give you the Ka for HCN. So this is at the end of whatever chapter this was. I cannot remember. But I think it's the acid-basis chapter. This is at the end of the chapter. So for NaCN, you're going to put NaCN in water. And that's going to create CN minus plus water would create HCN and OH minus. And we know Na plus is a spectator ion, so we can automatically just cross it out and you'll be left with CN minus. So then we're going to do an ice table. And you have 0.175 molar for this. All right, what is our issue here? Can we use Ka? No, because we have a basic solution here. So you have to solve for Kb. We know Kw equals Ka times Kb, and that value is 1 times 10 to negative 14. So we're going to do 1 times 10 to negative 14 divided by the 4.9 times 10 to negative 10 to get your Kb. And your Kb would be, what number is this? It would be 2.04 times 10 to the negative 5. So then you'll have 2.04 times 10 to negative 5 equals x squared over 0.175. Your x would be 1.88 times 10 to negative 3. If you do the negative log of that value, you get 2.72. Is that our pH? No, what is that? That's your POH, so you're not done. From the beginning, you should have went back to your answer choices and crossed out everything that wasn't basic. So you should have crossed out C and A. So that way you wouldn't pick something that says 2, like, oh, that's the answer, I'm done. No, you're not. This is your POH. And you know 14 minus POH will equal your pH. So 14 minus 2.72 would give you 11.28. So your answer should be B. Is everyone okay with this? This is live streamed. Huh? What'd you say? 31? 31 is A. Question? This is a common ion effect. Well, common ion effect effect, I think, actually took place in the titration chapter, right? When we did the KSP. So this is sort of the common ion effect, but not necessarily the common ion effect. You're just starting off with the conjugate base versus the acid. So you're just putting the conjugate base in the water. I don't know if I put a question with the common ion. This is buffers. Yeah, I actually didn't put one with the common ion effect, but I think that more so takes place with the KSP versus at this point. This point is just you recognizing that NaCN is the conjugate base of the weak acid. So you're just going to flip your equation. You're just going to do the CN minus in water and solve for it that way. Okay, let's move on to the next question. So we have 33. Which acid has the largest Ka? Do you have a periodic table? Yeah. Oh, thank you. Yep. I left mine in the start lab.
You can just take it up there.
It's not the heaviest one. It's okay. I don't need it. All right, what's the answer? It is A. Why is it A? I cannot hear you. The larger the Ka, the weaker the acid? Is that what you're saying? I think the larger the Ka, the stronger the acid. But how do we know? Because these are all weak. So, yeah. To dissolve. Well, then how would that connect to Ka? How can you connect that to Ka? You said the easier it is to dissolve the what? The greater the Ka. And you said larger ions are harder to dissolve. So therefore, it would have to be the smaller one, which would be A. They also have a section in your book that talks about oxyacids, and that's where you'll find this. So they can either ask you a question like this, and they'll keep the same, like say they'll all be HCl, and they'll just change the oxygens. Now, which one would be have the largest Ka if they were just changing the oxygens? Huh? Yes, the one with the most oxygens. So you should know each question that could come up, this one or the other one. If it was HClO2, HClO3, HClO4, this one would be the highest. In this case, it's the highest because of what he said. So if the larger the ion, so as you go down, this is going down the periodic table. So the larger the ion, the harder it is to dissolve. Okay, number 34. Which species is a Lewis acid? It's not B. What do Lewis bases have? I can't hear you. Lewis. We're talking about Lewis here. We're not talking about Bronsted, and we're not talking about... Huh? Yeah. Okay. What was the other person, though? BronstedLowry and... thank you. Arrhenius. Yeah, we're not talking about those guys. We're talking about Lewis. So Lewis has to do with the empty orbital or electrons. So if you were to draw out NH3, you have a lone pair right here. So this is electrons to donate, right? This is going to make it a Lewis base. F minus has a full shell of just electrons to give in lone pairs. So it can't be this and it can't be this, but you can determine this, so the answer is A. If you see boron and if you see aluminum, those would be your Lewis acids. Oh, wow. Yeah, if you were to see aluminum or boron, that would be your Lewis acid, because those are the exceptions that you learn from Chem 1 that can have an empty orbital. Yes, you have to think about Chem 1. All right, let's do number 35. Which solution would be a buffer? And before that, what is the definition of a buffer? No. If they were to just say conjugate acid, base pair, whatever, that's wrong. You want to look for the problem or the answer that says significant amounts of a weak acid or significant amounts of a weak base with significant amounts of its conjugate acid or conjugate base. It has to be significant. It can't just be any value. So all of these are significant values. They're all the same. So we're not looking at that in this problem. What we are looking for is if it is a weak acid and conjugate base pair or a weak base and conjugate acid base pair. So what would be the answer for this problem? So it's not A and it's not C. So for B, you have HNO3 and then you'll have NO3 minus. And then for D, you would have HNO2 and NO2 minus. Oh wow, I picked the wrong answer on my thing. Okay, I have to check or fix this. Okay, which one's a weak acid? B is a weak acid? D. Okay, so the answer is D. All right, number 36. What time is it? Okay, I'm going to have to go a little bit faster because we have 20 minutes. All right, so a 1 liter buffer solution contains 0.1 molar of acetic acid and 0.1 molar of sodium acetate. And the value of Ka for the weak acid is this. We want to calculate the pH after adding 0.01 mole of solid NaOH to the buffer. So what's the Henderson-Hausbach equation? You have pH equals pKa plus log of A minus over HA. So A minus would be the conjugate, right? So we have pH equals pKa. pKa is the negative log of the Ka. So in this case, the pKa would be 4.74 plus log over our conjugate base would be the acetic or the acetate, sodium acetate. So it would be 0.100 mole over here. And then you'll have 0.100 mole of the acetic acid on the bottom. So if we're adding a base, your base is going to neutralize the acid, correct? So it would be subtracting from the acid. So I'm just going to go ahead and subtract 0.01 from the bottom and add 0.01 at the top. When you do that, you're going to get the answer for 36 to be 36 would be A. All right, number 37. A buffer contains equal amounts of a weak acid and its conjugate base and has a pH of 5.25, which would be a reasonable value of a buffer pH after the addition of a small amount of acid. So this is kind of connecting to the previous problem. So if you're adding additional amount of a small acid, well, in the other problem, we started at 4.74, right? And we added base to it. So it went up to 4.83. So it only moved a little and it went more basic. But in this problem, we're moving a little and we're going more acidic. So what would the answer be? B. And you guys could have crossed out A and D. And same with before, you guys could have crossed out C and B. Okay, number 38. A buffer is 0.1 molar in NH4Cl and 0.1 molar in NH3. When a small amount of HBr is added to this buffer, which buffer component neutralizes the added acid? The answer to this would be C. Number 39, we have 3 15 milliliters acid samples, and they're all titrated with 0.1 molar NaOH. If HA is a weak acid, and HB is a strong acid, and H2C is a diprotic acid, which statement would be true for all of them? So if you were to remember the graphs, the weak acid, strong acid, and diprotic acid all look different. So at their first equivalence point, they won't all have the same pH, because it was with strong acids and strong bases where their pH was 7. With a weak acid and a strong base, it was less, and in a strong base and a weak acid, it was more, or whatever. I'm mixing those. But the A would be incorrect. They won't all have the same initial pH, because a weak acid and a strong, weak acid and a strong acid won't have the same pH. And the final pH, if you went back to the graph or the drawing, they won't have the same final pH, but they will all require the same volume of NaOH to reach the first equivalence point, because what is the definition of equivalence point? Equal moles of acid and equal moles of base. So the answer would be D for 39. Number 40, you want to calculate the molar solubility of lead 2 bromide. So I'm just going to do this very quickly so we can get through harder problems. So you have KSP equals that value. And you know PBr2 at equilibrium would create Pb2 plus and 2Br minus. So you start off with 0, and this would be plus S and plus 2S. And so your KSP would equal S and 2S squared. You'll have KSP equals 4S cubed, and then you'll just solve for S, and your answer will be B. All right, for number 41, which buffer system is the best choice to create a buffer with pH 7.2? How many people say A? How many people say B? How many people say C? And how many people say D? All right, the answer is actually C. So ammonia and ammonium chloride. So acetic acid and chlorous acid are all weak acids, correct? So it should be closer to 7, but not really quite 7, right? So these you can cross out. Nitrous acid is the same thing. It's a weak acid. Ammonia is a weak base, however, with its conjugate base. And that would be closer to the base range of 7.2 rather than the acids. All right, number 42. Which statement is true for the freezing of liquid water below 0 degrees Celsius? So does liquid water normally freeze below 0 degrees? Yes. So the delta G should be what? Negative. So you can go ahead and cross out C and go ahead and cross out D. Is freezing exothermic or endothermic? Huh? Huh? In every case. Huh? Endo? So, exo. I always think of it as you need energy to break bonds. In this case, you're making bonds, so you're going to be releasing energy. So your delta H should be what? Negative. And then also to check for delta S is what? What is delta S? Entropy, right? And entropy measures what? Disorder or chaos. So if you're going from a liquid to a solid, you are decreasing in entropy, so your delta S should be negative. The answer should be B for 42. All right, 43. Under which set of conditions is this most likely to be negative? The answer for 43 is B. How did I do that? Okay, so there's two delta G equations that you guys should keep in mind. You have delta G standard equals negative RT ln K. You also have delta G equals delta G standard plus RT ln Q. So we're trying to find how can we make this value negative, right? And you can make it negative if your Q value is the smallest, I believe. Yeah, you want to make that the smallest it can be. So with B, that's how you would do it. All right, 44. Which process results in an increase in entropy of the universe? 44 is D. 45 is C. In which case is the reaction spontaneous at all temperatures? 46, you guys should be able to do. You just need to make sure that your temperature is in Kelvin and your delta H and delta S are in kilojoules. And if you do that, you would get D for 46. All right, and this one is supposed to be number 47. I want to note that it's delta G standard. So you're using dG equals negative RT, this one, not the Q. And so in this case, the answer would be C. I'm just going fast so you guys can have, if you guys have any extra questions, you can ask me before we leave. All right, and then 48, which statement is true for voltaic cells? A is true, but what about B? Yes, all of the above are true. So 48 is D. Don't be so quick to answer a question. Make sure you read the whole entire question. All right, number 49. The zinc and zinc 2 plus electrode has a standard electrode potential of negative 0.76 volts. How does the relative potential energy of an electron at this electrode compare to the potential energy of an electron at the standard hydrogen electrode? What is the standard hydrogen electrode voltage? 0. So we're comparing 0 volts and negative 0.76 volts. So which one is more likely to be oxidized, 0 or negative 0.76? All right, well, we're not really talking about that. We're talking about potential energy. Well, if you are oxidized, where are you occurring at, the anode or the cathode? At the anode. So this is oxidation at the anode. And we flow from anode to cathode, right? And we flow from higher potential energy to lower potential energy. So the answer should be A. An electron at the zinc 2 plus electrode will have a higher potential energy than the electron at the standard hydrogen electrode. That's something that you should know. And it's also on the table of values. The standard, they'll have 0 in the middle of them. Okay. number 50 and 51. Copper is plated onto the cathode of an electrolytic cell containing CuCl2, and then how long does it take? All right, so you have Cu solid leading to CuCl2, right? We just need to figure out what's the mole of electron. So if you're going from 0 to +2, because this is -1, and this is -2, and then this would be +2. I just did that real quick. But if you're going from 0 to +2, how many electrons are you losing? Yes, from 0 to +2. You're losing 2 electrons. So this would be your half reaction will look like. So then we know amperes equals coulombs per second. And then Faraday's constant is coulombs per mole electrons. And then we're sharing 2 moles electrons. So in here, this problem, you're going to go from 111 milligrams to grams. You're going to use the molar mass. The moles will cancel out with the 2 moles of electrons, and then you can use Faraday's constant. And then you can use the amperes that was given. And after all of that, you'll get 89 seconds. Excuse me? There is no formula. This is all dimensional analysis. All right, so the answer for number 50 is C. And then for 51, which form of radioactive decay would you most likely be able to detect if it were happening in the room next to you? It would be C, gamma. All right, so for your ACS, just make sure that you are practicing the questions with alpha emission, beta emission, gamma emission, and know like what those values are. I would focus on reading your textbook and outlining it more so than focusing on math problems, because the ACS won't have that many math problems. But if you are in Hampton, he may give you math in his additional questions. Excuse me? Yeah, I just went through the book and picked out all the conceptual questions that I think you guys should really like focus on versus the stuff that you may not need to focus too much of your time on. But I also am going to put the answers, the bolded answers, on the website as well. Does anyone have any additional questions? Wait, you said you're going to Yeah, I can't hear you. I'm not sure. I think it's to this. But yeah, this is live streamed. So tomorrow you guys should be able to look at my video again and go through it if you had any questions. Yes? Are you also posting like the work, even though like I know it's not like that? No, because most of these questions were from the book. Oh, okay. Like I literally just went through the book and just picked out questions. Yeah.
Number 38. I didn't quite get it. I didn't write down.
Oh, number 38.
Yeah.
My work is very messy and like unorganized. Okay, 38. Did I write it on here? Oh, I did. There wasn't any work for 38.
Yeah, I just didn't understand how you got the answer.
Oh, okay. So when a small amount of HBr is added to this buffer, which buffer component would neutralize the added acid? So remember from here, if you, okay, so you have NH4 plus, because this is a spectator, Cl minus, so you have NH4 plus, and you'll have NH3. So if you're adding acid,